Okay, so we are on topic 2, lesson 5. It's the last lesson for topic 2. We're doing Okeechobee. So right here, it shows you your learning goals. You're going to identify geometric figures with line symmetry and rotational symmetry. Identify lines of symmetry for different geometric figures. Describe rotations that carry a figure onto itself. Describe reflections that carry a figure onto itself. These are just like your I can statements. Okay, so the first thing you're going to do is you're going to do this review on the getting started. So go ahead, give it a go and pause. And here's the answer. Okay, moving right along. Let's see, how do you know that two numbers are opposite when plotted on a number line? Because if we look at, just for example, -8, the opposite of it would be on the other side of the 0. Next. Okay, so now you're going to consider these different shapes shown. And now's the time that the student in charge is going to pass out patty paper to everybody. Once they pass out that patty paper, you're going to want to copy each of these shapes onto your patty paper. Go for it, pause. Okay, what you need to do is you need to take each of those shapes and you need to see if you can fold them in half so that half of the figure lies exactly on the other half of the figure. And if you can, how many different folds can you do to determine that? So determine whether you can, well, let's just start with that. Go ahead and pause and give it a go. Okay, so here's my perfect drawing again. All the red lines are where you can actually fold it. The circle, of course, you can fold it in infinitely many places and fold it onto itself. The only two that you can't do anything is your right triangle and the parallelogram. So the other thing you're going to do is you're going to determine whether you can rotate each figure so that it looks like it did before the rotation. So if so, there are other rotations that will do this. Are there other rotations? So go ahead and give it a go and see how many times you can rotate it to rotate it onto itself. Okay, so here's the possibilities for the rotation. Each of them can be rotated 360 degrees, duh. What you're doing is you're stabbing it in the middle and then you're trying to rotate it onto itself. So what you could do is just put it on your paper, stab it in the middle, and then see how many times you can rotate it. You'll notice for the hexagon, you can do 6 rotations. You can do infinitely on the circle. For the parallelogram, you can do 2 rotations, and for the star, there are 5 rotations. Okay, now what you're going to do is you're going to name all of those shapes. So go ahead and take a second and see if you can name all those shapes. Go ahead and pause. Okay, so the names of the figure, it's a regular hexagon. Regular meaning all sides are the same length. A circle, isosceles trapezoid, mean that 2 sides are the exact same size. A parallelogram, a scalene right triangle, meaning none of the sides are the same length. And then a star. Okay, grab your highlighter. You need to highlight. A plane figure has reflectional symmetry. If you can draw a line so that the figure to one side of the line is a reflection of the figure on the other side of the line. Then it says, recall that the line you drew on each shape is called the line of symmetry. So, and we know because you folded them that some of them will have more than one line of symmetry. Which shapes have a reflectional symmetry, which means when you do your line and you take your reflection tool, you can put your reflection tool on that line and it will reflect it onto itself. So go ahead and give it a go with your line of symmetries and see if you can figure out which ones have reflectional. Go ahead and pause. Okay, so when you used your reflection tool, you should have seen that the regular hexagon, the circle, the isosceles trapezoid, and the star all have a reflectional symmetry. Okay, so now it says, consider the equilateral triangle shown. It has 3 lines of symmetry. Draw these lines of symmetry. So go ahead and pause and draw them. So these are the lines of symmetry for this triangle. They are reflectional lines because if I put the reflection tool on there, I'll see that it reflects onto itself. Now, how many lines of symmetry does the rectangle shown have? And so go ahead and Draw the lines on the rectangle. Okay, here are the lines of the rectangle. If you want to explain your reasoning, you can just put the reflection tool on there, and you can see that's the only places where it will reflect onto itself. That's the only lines of symmetry. How many lines of symmetry are there on the square? Draw the lines of symmetry, so go ahead and give it a go. Pause. Okay, so for the rectangle, we should say 2 lines of symmetry. And then for the square, there are 4 lines of symmetry. Okay, get your highlighter. You're going to highlight a plane figure can also have rotational symmetry. If you can rotate the figure more than 0 degrees but less than 360, and the resulting figure is the same as the original figure in the original position. So it means you're stabbing it in the middle, you're rotating it more than 0 but less than 360. So you have to be able to rotate it at least once before you get to 360. So what you're going to do is you're going to go back to your shapes, take your patty paper, put them on top of the shapes, and you're going to see how many rotational symmetries. So you're going to put it on top, stab it in the middle, and then see if you can rotate it more than once before you rotate it 360 degrees. Go ahead and pause and go. Okay, so the regular hexagon, the circle, the parallelogram, and the star all have rotational symmetry. Do you think that the given shape has rotational symmetry? Why and why not? So go ahead and see what you think. If you want, you can copy it onto your patty paper and then try it and see if it has rotational symmetry. Pause. Okay, what you should have noticed is this one does have rotational symmetry. If you stabbed it in the middle, you can rotate it 90 degrees, you can rotate it 180 degrees, or you can rotate it 270 degrees. Okay, can a shape have both reflectional and rotational symmetry? What do you think? Pause. The answer is yes. The regular hexagon, the circle, and the star have both reflectional and rotational symmetry. Okay, you've also identified transformations that carry figure onto themselves. So reflectional and rotational symmetries are properties of figures that can be carried onto themselves just by doing reflections or rotations. Okay, now consider the 4 shapes shown. Describe the reflections and rotations that can carry each figure onto itself. I want you to highlight. For reflections, identify the line of reflection. For rotations, describe the rotation angle and center of rotation. All right, go ahead and do a pause and see if you can describe the reflections and rotations for each of these. Okay, so the reflections on the hexagon, you have 8 lines of reflection. I have them drawn. You can rotate 45, 90, 135, 180, 225, and 270. For the for the isosceles trapezoid, there is 1 line of reflection. I drew it. There's no rotation. For the equilateral triangle, there's 3 lines of rotation. You can rotate 120 and 240. And for the rectangle, there's 2 lines of symmetry, and you can rotate it 180 degrees. I mean lines of reflection. Okay, so Clark says a horizontal line of symmetry in the rectangle means that a reflection across that line carries the figure onto itself. He also says that it means that a 180-degree rotation will carry the figure onto itself. Is Clark correct? Does his reasoning apply to all figures? All right, go ahead and pause and give it a go. Okay, if you notice the rectangle, yes, if you reflect it over that 1 line, that horizontal line, it will map onto itself. And if you rotate it, stab it in the middle, like right here, and then rotate it 180 degrees, it will map back onto itself. But take a look at the isosceles trapezoid. The isosceles trapezoid, this one here, if we go along this line here, it will map onto itself. But look at the red. When you do 180 degrees, it will not rotate 180 degrees and map onto itself. So he is right on the reflection, but not on the rotation. Okay, so here we're looking at a vertical line of symmetry. So it says which letters have a horizontal but not a vertical line. So if we look, this one here has a horizontal, but it will not reflect on itself with a vertical, whereas the others all have horizontal and vertical. So it's C. Okay, which letters have a vertical but not a horizontal line of symmetry? So this one here has a vertical, but it does not have a horizontal, so it's M. And then if you look, because X and H, they all have vertical and horizontal, and B only has a horizontal. Which letters have both horizontal and vertical? That would be H. H has horizontal and vertical. And then which letters have a rotational symmetry? That would only be Z, because none of these others can I stab and go less than 360 but more than 0 and get them to map onto each other. Okay, so now you're going to do the